Hey guys, this is Mitch with Findpoint CGI, and today we're going to talk about how to create a very basic enemy controller system. So we're going to go through the process of building out our state machine. We are going to build out the ability to patrol from point to point. We are going to add in the ability to chase after the player, and we're going to add in the ability to hunt the player. Now, the hunting system is not as in-depth as I'd like it to be, but we are going to make it so that it goes to where the player was last located. He kind of sits there and waits for a couple seconds, and then he kind of moves on back to his patrol. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing we have to do is we need to kind of plan out what we're going to build our enemy here. Now, if you want to skip this, you can. Just jump to the next time code in the chapters section in the description, and you guys can just go ahead and get right into coding and get right into development. But I figured it would be good to take some time to actually plan out what we're thinking here. So when we plan this out, what I like to do is I like to look at things as if it's a giant state machine. And one of the big things about state machines is they are designed to kind of segment out your code, okay? And generally speaking, when I design characters or enemy code, I like to just kind of approach it as here's what this character is going to do in this state, and here's how this character is going to approach a thing, right? So to do that, we're going to use Draw.io. Now, I know you guys have seen Draw.io in previous tutorials, so I'm not going to go through too much of it. But first, we will create our basic states. So the first state that our character is going to have, or our enemy is going to have, is the patrol state. And that's a state that character is going to walk from point to point to point, right? So for patrol, it's going to, well, I'll drag this guy out, and I'm going to actually make this, and let me shut off my dark reader, which is a great add-on, by the way. I know, oh, my eyes, right? But it's a little harder to see if you have dark reader on when you're doing this. So what I'm going to do is I'm going to go to my text, and I'm going to drop this up, and we're going to say this is the patrol mode. So the patrol mode works very simple. We are going to get our next path, and then we are going to navigate to that. We'll say instead of get our next path, let's get our next waypoint, and then we're going to get direction, and then we'll set our velocity, right? And then we are going to basically move towards point. And that's basically all we'll be doing here. Okay? And when we do this, we need to have some way to break out of this loop, right? So we will drag in a little conditional here, and we'll say, am I at my point? And we'll just drag this guy here. If you are not at your point right here, then you'll do that. And if you are, then we're going to change our state to wait. And that will be our patrol state. Now, our next big state that we need to have is our wait state. Okay? And I guess we probably should start from the beginning, right? Instead of jumping into code designing here. Let's duplicate this a few times. Let's talk about the different states we have. So we have the wait state. We have the hunting state, right? Because it's going to be hunting you. If it sees you, it will hunt you, right? It'll chase after you. It'll look for you, things like that. And then we should have a chase state. So the difference between a hunting state and a chase state is basically if it hears a noise, it's going to hunt for you. It's going to say, oh, what was that? And it'll go after that general location. It'll kind of search the areas around that location. Chase state, it has seen you. So therefore, it's going to run after you. He's going to chase you and try to catch you. Okay? We may want to make an additional state, but we can always come back to this and change it later. So in our wait state, what is our character going to do? Okay? Well, first, if we go back to our patrol state, right? We'll come here and we'll say set wait timer. because we need to wait for a specific number of seconds, right? So let's do that first, and then we'll set our wait state. So that way we're waiting. In our wait state, what are some things that our wait is going to do? Well, first, he's going to stop moving. And then we should probably put in some way to look around, right? Now, in this specific tutorial, we might not do this. We might just make him wait because this is a very basic AI tutorial, right? This is going to be a very, very basic AI. So I don't want to go too complex because we'll just do a part 2 that makes it way more complex. We'll need to drag this guy back. So basically to say that it's going in a loop. So it's going to loop around. Now we need a way to break out of this loop like we've done before. So we'll drag this guy in and we'll say, is wait time done? Question mark. Now, we don't necessarily need to do this. And actually, I think, you know what? I think I'm not going to do that. Instead, let's take a timer, and we don't really have like, unfortunately, you know, these shapes don't really do well for, you know, Godot style code, but let's just use this little ellipse here and say wait timer has finished. And we'll just drag this guy in here, and then we'll just drag an arrow to this guy, and we'll say once it has finished, change state to patrol. And let's actually set next destination. There we go. So we'll set our next destination, and then we'll change our state. I think that'll be a little bit better. And there we go. So that's kind of what I'm thinking for these two states. So he's going to walk. He'll go get his waypoint, get the direction, get the velocity, move towards that point, check if he's there. If he is, he goes to sets his wait timer for whatever the time is. And then he goes to wait state. When he's in his wait state, he just sits there and looks around and scans for the player. And once the wait timer has finished, he's going to set his next destination and then say, hey, go back to patrol state. Okay. So these two states are very much dependent on each other. Now, during the hunting state, the enemy is going to go towards the player, right? So what we'll do is first, he's going to ray cast to player. Then they're going to go towards that player. And then once they've gotten towards the player, once they get within like a specific distance, so get with, then they will look around. So we're going to have them search that general area. So let's have them, and I don't know if we're going to get to this in this specific tutorial, but what we'll do is we'll have the character look around the general area, and then if they happen to not find them, then if they find the player, they will move to chase state like that. There we go. And then if they don't, then they're going to move to their actual patrol state. So we'll bring this guy down here and say return to patrol. And that should be a pretty good, you know, hunting system, if that makes sense. Now for the chase state, what's going to happen is it's going to ray cast to player and get their position. And then it will set destination to player. And then we will have them change speed to sprint, and then they will come in here and chase after the player, right? So chase after player, and then if they catch the player, they will attack. Now, if they don't catch the player, like this, if they don't catch the player, they'll still set their destination. And then we should have one other check in here, is if the player's out of range. So did they catch the player? No. Are they in range of player? And if not, then they will return back to their patrol state. If they are within player, then they'll set their destination like that. And we might want to move this guy around a little bit, but I think it'll be fine. So we'll do that. And if they catch the player, then they will attack. And we might need to make some adjustments here. The hardest part of concepting out your stuff is actually making sure your stuff flows well. That makes sense. And I think that will work for the chase state. Now, your other big thing that we have to look at is how are we going to do detection? And how we're going to do detection is going to be pretty simple. Basically, what we'll do is we'll have rings of detection. So what I'm thinking is we're going to have a ring like this, and then another ring that's slightly bigger, and I'll have to send this guy to the back because I didn't realize that. So we'll do something like this, and this will be like their listening rings, right? And then same thing with sight. They'll have sight rings, which will basically be these cones. That'll be like this. And then we'll have another sight cone like this, which will be close and far sight, if that makes sense. So that's kind of what I'm thinking. And basically what this one will be is I can hear player investigate. I can hear player chase. And then same thing with here. I can see player investigate like that. And then I can see player chase. So basically what's going to happen is we will change our states based off of which cone happens to see the player. Now, we are going to need an entire sound system, and we'll probably need to get more in depth with these systems as we go. But for our detection system, this is kind of what I'm thinking. And when in the future, what we'll do is we'll set this so that the if the player is further than like X light level, then I can see the player. Or if it's louder than X amount, then I can hear the player. And we'll put a very basic check for that. And we'll probably have to come back here and plan this. But this is what I'm thinking we'll do specifically for this tutorial is just this bit here. And we'll go from there. So let's jump into Godot and let's go ahead and get started. Okay, so the first thing that we have to do when we're creating an enemy character is we need to build the scene. So we'll head up here to our node 3D. We're going to right click and add in a child node. Now this child node is going to be a character body 3D right here. We're going to double click that guy and we will rename it as a enemy. And that should do it for us. Now, what we'll do is we'll right click and we're going to add in another child node and we need to have some kind of collision, right? Any type of kinematic body needs to have collision, or I guess in this case, a character body. You're going to probably hear me call it a kinematic body because that's basically what it is. But we'll type collision and we'll add in a collision shape 3D. We'll click on that shape and turn it into a capsule shape. And then we'll kind of drag this up just like that. And we're going to want to give it some kind of mesh. A enemy needs to have some kind of shape to it, right? Or some kind of mesh. So we'll right click our enemy. We'll add in a child node. We'll add in a mesh and we'll add in a multi-mesh instance. And then we will go ahead and make it into a capsule mesh like that. And we'll just kind of pull this guy up until he's about, somewhere in this vein. And I know you guys really can't see it, so let me move this guy over here and you guys can see what he looks like. So this is what we have so far. We have a collision shape, a mesh instance, and a character body. Now I'm going to duplicate this mesh instance here, just like this. And I'm going to rotate it 90 degrees. And I'm going to give this little guy some kind of a nose or something like that. So we'll just kind of scale this guy down like that, and we'll pull this guy up here just like this, and we'll give him a little nose. That way we know which direction he's facing, okay? And if you look, his nose is facing the x-axis, and we might need to make some adjustments, but we'll see. Hopefully we have it correct. If not, we might need to move this over a tiny bit. Now, when we want to do like detection and things like that, we'll need to come back to our enemy. But for right now, we're just going to make it so that he can walk from point to point, and then we'll get into detection and detecting the player and chasing the player and things like that. So what we'll do is we'll right click our enemy. We're going to attach a script and we'll name it enemy.gd. And we don't need to use the basic movement. We can just grab the node default and we'll hit create. And you will see that we have extends character body, ready, and process, which is perfect. That's what we'd like. And you'll see if we come down here and we look at our scripts, you'll see our enemy script isn't here. But if we come up here to our scenes, it is right here. So let's drag that guy right down there into our scripts folder. Now, again, if you have a different organization structure, that's totally fine. Go ahead and just do whatever it is that you're going to do. Now, first, we need to set up a bunch of things, okay? For us to be able to move our player via the navigation system that's built into Godot, it's going to require us to do a lot of legwork to get this moving. So we'll come back to our node 3D and let's come back to our 3D scene and let's right click, add in a child node and add in a navigation region. Okay. And a navigation region basically allows us to create a nav mesh. And for those of you that are new to game development, nav meshes are basically a way for our enemies to path find, which is to find a way to get to another point. So they want to go from where they are to where they want to go. So like, for instance, the player, they need to actually find out how to get there. And that's what nav meshes do, is that they bake, think of it kind of like a 2D plane, right? A 2D picture almost, and says, okay, well, I want to get from point A and I want to get to point B. How can I get there? And it kind of traces paths to try to determine how to get there, if that makes sense. So what we'll do is we'll grab our navigation mesh. We will come in here. We'll create a new navigation mesh. And then how navigation meshes work in Godot 4 is basically if you have an object and you put it underneath the navigation region, when you click this big old button right here, you will see that it's going to bake that, right? Like that. Now, something you'll notice is this isn't cut out specifically for your mesh. So that's because this object is not under this mesh. So if we put it underneath it, then we click bake, you'll see that now we have a hole here. And that's what we want, is we want a hole so that way the character doesn't attempt to walk through this object, because obviously it can't, right? This object has collision. Now there's a lot of options in here, and I do go over it in my Godot 3.5 navigation 3D tutorial. So if you want more information, check that out. And it will kind of give you a step-by-step, here's what all this means, here's why this exists, here's how to do all these things. In our case, we don't need to worry about that, but just know that these are a lot of really, really cool options, okay? Now, once we have our nav mesh baked, we can actually start building out our enemy. But our enemy doesn't know where to actually go to without having some kind of resolver, right? Some way to interact with that navigation mesh. So we need to actually add that to our enemy. So we'll right click our enemy, we'll add in a child node, and we'll add in a navigation agent 3D. And a navigation agent 3D allows us to navigate in 3D. I mean, it's pretty self-explanatory. So we'll hit create, and then now we can actually start coding. So we'll click on our little script icon. Now, if you remember back when we were doing our design, we talked about doing a state machine, okay? And to do a state machine, we could just do something like an integer or something like that. But generally speaking, when you want to do a state machine, you want to use an enum. So let's add an enum right here. So we'll type enum states. And for our states, we'll have patrol, comma, chasing, comma, hunting, and waiting, okay? And those are our four major states. Now we also need something to house those states. So let's say var current state states, and we'll need to set our state on ready. So current state is equal to states dot patrol, because that's what we start off in, is in patrol state. And then we will need to set up our state machine. Now, when you set up a state machine, you should use a switch to do that. Now, GD script doesn't have a switch. Now, if this was C sharp, we would just use just a standard switch. But since GD script doesn't really have a switch, they have the match operator. So we'll type match current state. And this is going to require us to have some kind of state to match on. So if we hit enter, we can type states dot patrol colon and then pass. And that should set up our basic patrol state. So now we can just grab this guy. We can paste it, enter, paste it, enter, paste it, and then grab our different states. So chasing, hunting, and waiting. And that should basically have a very basic state machine set up. So the way this is going to work is, since our current state is patrol, anything inside of here is going to run continuously. If we were to change our current state to something like hunting, then just the code inside of here will run. This allows us to segment our code and to make our code a bit easier to manage. We can actually dump all this out to functions and then just say, here's my patrol function, here's my chasing function, here's my hunting function. And we can have branching logic from there. You could actually have substates and things like that that really can make your enemy extremely verbose. So let's set up our patrol state. So when we set up our patrol state, we're going to need to have a navigation agent 3D, and we already have one right here. So let's just come up here and get a class reference to that. So we'll say var navigation agent, and we'll make the type navigation agent 3D. And I know that you can just kind of set it by doing this $, and then navigation agent 3D like that. But I've noticed that I've had problems with this in the past. So instead, I'm going to initialize it down here because I have seen it break on me a few times. And also, I can't spell navigation, can I? So we'll say navigation agent. There we go. And now that we have our navigation agent, which NAVI, there we go. Now that we have our navigation agent, we need to set our destination. Now, we don't actually have a destination for our navigation agent to, exist with, right? But what we can do is we can make an array of objects, and we're going to want to use something to mark, like almost like flags, right? So think of how navigation works is you have these flags, right? I want to go from point A to point B. And what we can do is we can basically say, okay, I'm going to have a list of flags for my character to rotate between. Okay. So we can come in here and say var waypoints is an array of marker 3D. And that's where markers actually come in handy. Markers are basically a way to have a position in 3D space that you can just say, this is a position that exists in 3D space, right? And that's really nice for when you're doing waypoints. Now, we also want to export this out. So we'll put @export bar right here, and that will allow us to export that out. So if we click on our enemy, you'll see that we have a waypoints array object right here, and we could just add in a couple of them and then assign waypoints to our enemy. So our enemy will have dedicated patrol points that they can use to move around. Now, we also want to keep track of what index we're at. If we're patrolling to a specific place, we want to keep track of the last one that we're going to. So that way, when we stop and we're in our waiting state, we know where we're going next, if that makes sense. So we'll put in a var waypoint index, and we'll make that a type integer. There we go. So now what I'll do is on startup, I'm going to set my initial location to where I'm walking to my first waypoint index. Now, we don't actually have a waypoint index, as you can see right here, or waypoint at all, but we can set it later once we get everything moving. So if we come in here, we can just say navigation agent dot set target We can pass in our waypoints, and we'll pass in our waypoint first position, first element dot global position. Now I am having some auto completion errors here, and I'm wondering why. It seems like GDScript is not liking this navigation agent 3D. I think it thinks that I'm reassigning it or something. So we might need to manually type these out because for some reason it's not liking it. So next, we need to come down to our patrol and we need to set up our patrol code. Now, our patrol code should be pretty simple. What we'll do is first we need to check if our navigation is finished. So if navigation agent dot is navigation finished, then we need to set our return because we don't want to do anything. So we'll return. We don't want to do anything. We just kind of want to pass and let things move. This is where we're going to change our state so that way we can just, wait. But this is where we're going to change our state eventually and actually, allow our character to move. But in our case, we don't need to do that just yet. We'll get back to it. Now, when we want to move, we need to set our target position. So we'll say var target position is equal to navigation agent dot get next location. What that's going to do is it's going to fetch the next location in our navigation path. So let's talk a little bit about how navigation kind of works. I think I talked about it a little earlier, but each path is made up of separate points. And the goal is for us to go from point to point to point and follow that path. So that's what we're doing here is we're just getting that next location. Next, we need to get the direction we're moving. So we'll say var direction is equal to global position dot direction to, and we need to pass it to our target position. And then we need to actually set up our velocity. So we'll say velocity is equal to direction multiplied by, and here's where we can set the speed of our nav agent. Now, if I come up here, I could just set up a speed value here, and let's export that. So export var speed, and we're just going to default that to something like 2 or maybe 3, and we'll just set this to speed. And now we can just call our move and slide, and that should pretty much do it for our basic movement system. So now if we come up to our enemy and then we go to 3D and we right click, add a child node, add a marker 3D, let's move that marker 3D over to something like here. And let's click on our enemy and drag our marker into. Click on our enemy 3D and click assign and then assign that marker 3D and hit OK. And for some reason, it's not letting me assign my marker. So instead, what I'm going to do is I'm going to clear this table and I'm going to come to my marker 3D. I'm going to go to node. I'm going to add it to a group and I'm going to call it enemy waypoint because apparently something is wrong here. So I'm going to copy this waypoint here and I'm going to go back to my script and I'll just manually add it. So what I'll do is I'll just say waypoints is equal to a new array, get tree dot get nodes in group, and I'm going to pass in that group name, and that'll basically just allow us to add our waypoints to our marker here because for some reason something's broken here and it doesn't really like it. So now if I hit play, let's see what this does. Well, first we have a get invalid index patrol, and my guess is because I did not mean to capitalize the P, so let's fix that. Let's make sure that this is all set correctly. It is, so let's try that. And now we got another issue, trying to assign a typed array with a different definition type. And basically what that means is that this is not the correct type for this. Now I'm curious if we just make it a non-typed array, so we'll just make it an array and then see what that does. Okay, so now we can actually run around and our guy is moving to our position. Cool. So let's add a light real quick so we can actually see what we're doing. So we'll right click, add in a child node, and add in a light, and we'll add in a directional light just like that. And I'm going to rotate this to be like this. And let's actually rotate this guy off to the side so we have a little bit of an easier time seeing what's going on. So if we hit play, you'll see our guy is moving. Awesome. So now, once he gets to this position, we need to make it so that he goes into a waiting state, right? We need to say, okay, I'm here, I'm going to wait. And then once a specific amount of time goes by, then I'll move to my next location. So let's go into our code here. So once we finish our patrol, right, we've gotten to our spot, right, gotten to our location that we're trying to get to, we need to set it up so that we can wait, okay? So when we hit our navigation finish, we will set our current state equal to states dot waiting, okay? And we will need to wait for a specific amount of time. Now, there are a lot of ways that we can do this, but one of the easiest ways is to use our little patrol timer, because that's what we have that for. So what we can do is we can just get a reference to our patrol timer, $patrol timer dot start. And there we go. Now, providing that this works, hopefully, because for some reason, again, my IntelliSense is a little funky with Godot 4, but providing that this works, it should go pretty well. Now, we may want to actually fetch a reference to a patrol timer. So instead of doing that, let's come up here and just say var patrol timer, and let's make that a type timer. And let's assign it right down here, much like what we're doing here. We'll just say patrol timer is equal to $patrol timer. And that'll just allow us to have a little bit more, flexibility here. And that's kind of the name of the game, is that I want this to be a little bit more flexible. So we'll say patrol timer, just like that, dot start. That's perfect. Now we need to hook up our patrol timer. If we're starting it, we need to have it so that our patrol timer will start, run, and then be done. So we're going to make it a one shot. That's what that option does, is it makes it so that it runs once. We'll say when it's completed on timeout, connect it to our enemy. And when it times out, let's set our current state equal to our states dot patrol. We can also set our waypoint index plus equals 1, and we can set our patrol point to its next location. So we'll say navigation agent dot set target location, and we'll set it to our waypoint index like that, and that will allow us to set our next location. Now, something that you might notice, or you definitely will find out when you test this, is this only works if you forever have additional items in our array, right? Because we're always just moving up. So we need to have a way to say if this is above our waypoint amount, then we want to not go back to 0, if that makes sense. So we'll say if waypoint index is greater than our waypoints dot size minus 1. And the reason why we're minusing 1 is because when we count our waypoint size, it starts from 1. But if we actually try to pull back our indexes, it starts from 0. So we need to minus 1 so that way our size counts for 0 as well. But if it is greater than our actual size of our array, then we want to set our waypoint index equal to 0. And that should solve our problem. So if everything's been done correctly, let me check to make sure that we should be good, because this is just going to run waiting, navigation finish, patrol timer. Yeah, that should about do it. If we come back to our marker 3D here and we duplicate it, we drag it over here, and we make sure it's part of our enemy waypoint, and we hit play, in theory, he will move to that point. And we have a crash, of course. Invalid function set target location in Nav Agent 3D cannot convert argument. Yep, from an object to vector 3. That's because we forgot to put global underscore position. And that should do it. Let me double check. Yeah, global underscore position. That should do it. So now let's try that again. So he's going to walk and hit it. He's going to wait for 1 second and then start walking back. Awesome. So now let's see what happens if he gets to that point. He starts walking to the other point. Great. So we have our basic enemy AI really started. He's doing things. If we want him to wait longer, we can just set our timer for a longer timer. A lot of times with patrol timers, right? Usually someone will stay there for like 3 to 5 seconds. So let's say 5 seconds. That's totally fine. And that's basically all we need to do for a basic patrol. Now, one of the big things you might notice is our enemy, when he's walking to his point, he's not actually looking at his point. He just kind of sits there and then just kind of walks back and forth, but doesn't rotate to match his point. You see that? So let's make him do that. So let's make a function called base direction. So we'll just say func base direction, and we'll pass in a vector 3. So we'll pass in a vector 3 direction, and we'll make that a type vector 3. And then we'll just close this off. And what we'll do is we will put in a look at, and we'll pass in a vector 3. And we'll pass in our direction.x, comma, our global position dot y, comma, direction dot z. And then we need to tell it which way is up. So we'll just say vector 3 dot up. And there we go. And it should be good to go. Now, something that we'll have to fix in a second, which I'll show you guys, is we're going to need to basically lerp this value to make it so it's a little bit less as snappy, but that's okay. We'll figure that out in a minute. Let's go up here, copy our face direction, and come up here and set our direction. So face direction. And I am having some bugs with my parsing, and this is with Godot beta 2, so I should probably upgrade to beta 3. So I'll be right back, and let me see if that fixes my problems. Hold on one moment. All right, so now that we're back here, let's check to see if this actually gets fixed. There we go. That's a lot better. Goodness, I don't know why it was being difficult, but now we're on beta 3, so hopefully that'll be a little bit more stable for us. So now that we've set our direction, let's test that and see what it does. So we'll hit play, and you'll see frankly, he's walking backwards. So let's try to fix that real quick. So instead of passing in our direction, let's pass in our target position, and then we'll probably just need to adjust our character to match. So you can see right there, it looks like something else that side. Let's see, what is that side? So let's take a look real quick. So he's facing this way, right? So if we set this as local, it looks like forward, according to Godot, is minus Z. So we will adjust for that. So let's drag this guy 90 degrees, and let's just make this forward, and that should fix our problem. So if we save that and rotate our guy real quick, just to see if we rotate him like, this, and then we hit play, is he facing the correct direction? He is. So it looks like it's minus Z is considered forward. So if we let him rotate, perfect. That's what we want. Awesome. So now that we have this, let's set up our basic detection system. Okay. And this is going to be a pretty dense system because we want to make it, useful. We want to make it good, right? So first, let's expand the size of this level real quick because this isn't going to work, right? It's way too small. So let's make it much larger because I want our character to have a realistic-ish detection system. And let's put him, I don't know, I want to say let's grab our player and drag him back some like this. And then let's grab our enemy and let's basically just right click him, add a child node and add in an area 2D. Now this area 2D, I'm going to call it hearing far. And then we'll right click, add in a child node and add in a collision shape. And we're going to make it into a gigantic sphere shape. Okay. And we'll pull this guy out to something pretty large. I mean, he is he's just like us, right? He can hear. So we'll just kind of pull it out to about here. We'll keep it just slightly out of our character's range. That way we can make it so that it's a bit more easy for us to test. We can adjust it later, of course. And then what we'll do is we'll duplicate this and put hearing close. And then we'll grab our collision and we'll just make it a nice, tight, close hearing like that. Awesome. It's a little on the hard side to see, and I'm curious. No, it's just really hard to see. I don't know where my hearing far. Oh, our hearing far got okay. I know what's going on. So our collision shape here, this reference stayed the same. So we need to right click this and make it unique. And then let's rescale this so that it works. So we'll just drag this guy back out like this. And there we go. So now we have two collisions. It's because we duplicated it. So when you duplicate objects in Godot, sometimes it likes to keep references. And that's to make it so that things are a bit more efficient for Godot at runtime. And we'll set up these two areas with their signals for on-body entered and on-bodied exit. You can see we have them right here underneath our node. So we'll double click that. We'll click on our enemy and hit connect. And then we'll click on our area, double click on body exit, click on enemy, connect, hearing close, on body enter, enemy, connect, hearing on body exit, enemy, connect. There we go. So now we need to know if we can hear our player. Now, we're going to have to create an entire sound system, right, to handle this based off of what the character's walking on, based off of pretty much everything, right? And that's going to be a monumental undertaking for us, and that will be an entire tutorial in itself. So first, we'll need to actually say, hey, players within earshot, right? So if we come to our close one, and the reason why I'm choosing my close one is because I want to illustrate a point here. If we just print whenever somebody or something comes into here, we could just say player is close in earshot, right? And then we hit play. You'll notice that that fires immediately. If we look at our stuff, player's close in earshot, but we're not close. And that's because anybody can fire this off. Any object in Godot that's considered a body object will fire this off. And you don't want that. Obviously, you want it to just specifically be for your player. So we need to check for that. So what we can do is we can say if, and we need something to define our player. So let's go to our node 3D. Let's go to our groups and let's add our player to the player group. Let's copy that group and then come in here and say if body dot is in group quote player, then player is it within earshot, within close earshot. If we just copy this and we duplicate it here, player has left close earshot. And then if we grab this guy, copy it, entered in body far, player is far in earshot. And if we grab this guy and duplicate it, we will say player has left far earshot. So now if we hit refresh, we have no logs here. If we come close, player is far in earshot. If we run right up there, player is close in earshot. He's walked past me, so it says player has left close earshot. And if we leave, player has left far earshot. So that's what we want, right? And that's basically how we can get our detection system working. And now we're going to do the same thing, but for our eyes. So we can come back to our enemy, go to our 3D script, and let's set up our eyes. Now, remember, we are going to be making a much more complicated system than this. And I know we're already probably about a half an hour into this tutorial, so I know that this has been a minute. But let's quickly build this out. So what we'll do is we'll basically create an area just like we did last time. So we'll type area 3D, and then we'll right click our area, add in a child node, and add in a collision shape, much like before. And we'll just double click our collision shape. And you'll notice if we go to our inspector, we take a look at our shapes, we have a separation ray, which is not quite what we're looking for, right? We have a sphere shape, a box shape, a capsule shape, a cylinder, which a cylinder might actually be better for our hearing. If we have multiple levels of something, we might want to use a cylinder now that I'm looking at it. But you'll see that we don't have any triangle shapes. So instead, we're going to have to build one. So what we'll do is we'll use a new convex polygon shape. And a convex polygon shape is actually really cool because it allows us to build our own collision shape. So what we'll do is we'll set this with 3 positions, okay? We'll say 0, 0, 0. We'll pull this guy out to something like, it's always so hard to see. So let me hide my navigation stuff, and we'll click on our collision shape, and we'll pull this guy out, and we'll pull this guy out. We'll pull this guy out, and we'll pull this guy out. Let's see if we can see anything. And I'm not seeing anything, so let's add 2 more shapes. There we go. It just took a few seconds. There we go. We just needed the additional shapes to help us build out this object. So we'll kind of start dragging this out so that way it kind of works. So let's see. So -5, this is going to need to be -6. So we'll make it about -6, -6. And we'll want this to be it looks like -7.5, we'll say. And we'll set this guy to 7.5, just like that. And that'll give us a nice, good triangle shape. And now we'll need to basically copy this guy, paste it, copy this guy, paste it, copy this guy, paste it, copy this guy, and paste it. And you'll notice that we basically just have a triangle. Wow. But this isn't going to work because it's just kind of sitting there, right? We want it to actually, have shape to it, have depth. So what we can do is we can drag this guy up, and you'll see suddenly our shape starts to come to life. We can actually just drag these guys up, and bam, we have ourselves a triangle shape, although my triangle's a little misshapen. So let's set this to something like 2, this to 2, this to 2. And then we can also come in here and pull this guy up. And now it's more like an actual sight cone that a person would have. Really cool. So now what we can do is we can say sight close. And then let's duplicate that and change this to sight far. Okay. And we can click on our collision shape and make sure we make it unique. So that way we don't run into that issue that we ran into earlier. And then we can take this and we can go, all right, we know that this is 7.5. We want the character to be able to see a far distance, right? So what we'll do is we'll expand his distance by a fair distance. So we'll put this at something like maybe 15 and maybe 15 and maybe something like 12 and I guess -12 and something like -12. Let's see if that's far enough. Is that far enough for our character to be able to see? I think it's close. Maybe we should go with 20 instead. Like that. And then let's kind of align this so it kind of matches. So something like, it looks like maybe -16 aligns fairly well-ish. Let me see. I think that will work. And then we'll do the same thing here. So we'll say minus 16.5. So minus 16.5. And then minus 16.5 as well. And then we'll make this minus 20 and minus 20. And it looks like we're going to need to readjust our Y values a little bit. Let me see. Because it's definitely not as wide as I'd like it to be. Let me see. Oh, it's because I set, is it because I set these guys to 2 by accident? Let me see. Yeah, I think it's because these are set to 2. So we'll set that to 0. We'll set this to 0. And we'll set this to, it looks like 2. I must have messed up my guys a little bit, but that's okay. Now you can make this as big or as small as you want for your sight far and sight close. But in my case, this is kind of how I'd like to have it set up. And of course, we're probably going to need to change this in the future anyway. So it's really not that big of a deal because once we actually start getting our gameplay going, we're definitely going to need to change this. So next we need to hook up our signals. So let's head over to our sight far here. Let's go to our node and do on-bodied enter. Let's connect that to our enemy and hit connect. And then we'll head back over to our sight far and then we will do our exit. So right click connect. Let's select our enemy, connect. And then let's do the same thing for our sight close. So body enter, connect, connect, and then on-bodied exit, connect, and connect for our enemy. Now, much like we did here where we checked if body is in group, let's do the exact same thing. So let's just copy this and paste it, and paste it. And I think we're missing one connection. Let's take a look. Oh, I hooked it to the wrong thing. It looks like I hooked it to something else. So we'll disconnect that, right click, body shape, enter, and let's hook it to our enemy and hit go. And that should do it. There we go. So we'll grab this guy and paste it, and then we'll say player has left close sight, and then we will say player has entered close sight, player has left far sight, and player has entered far sight. And there we go. So basically, that will be our basic detection system. Now, we're going to need to do a lot more work here to make it, actually worth something. But what we can do is we can set it up so that it changes our state to chasing and hunting and waiting based off of if the player is crouched or not. Customarily, I wouldn't do it necessarily this way, but we'll do it this way until we get our sound and our lighting system kind of built out. So we'll come down here and we need to put some booleans in here. So generally we want these to be global variables. So I guess I shouldn't come down here. I should come up and we'll just create a couple of booleans. So we'll say var player in earshot far, and we'll make that a boolean. And then we'll just duplicate that 4 times and say, well, I misspelled player, so that's not helpful. So let's actually spell player, not play. So player in earshot close, player in sight far, and player in sight close. There we go. And then we'll just come down here and set them up as we would expect. So on hearing far body entered, so I entered. So player in earshot far is equal to true. And if they leave, if we have an exit, then player in earshot false. And then we'll do the same thing for close. Player in earshot close is equal to true. Player in earshot close is equal to false. Bodied entered over here, we'll say player in sight far is equal to true. And then we'll paste that and change it to false. And we'll come in here and say player in sight close is equal to true. Copy that and paste it and set this to false. And there we go. And now we need to change our state as well to hunting or to chasing, right? Because they saw them or they didn't, or they're hunting them, right? Now, when we do this, we could do it in one of two ways. You can either set it here, right? When they enter, then they immediately are in hunting. Or if we want to make it a little more flexible, if we come up here during our patrol, we can just check for those Booleans and then do some additional checks. That way it happens every frame, so that way it's not only binary, right? So it's not if I enter, then it immediately checks, and then if not, then I'm good, right? That's not a good way to handle this. We want to check kind of every frame or every physics frame, if that makes sense. So if we come down here, we can check for that. So we will do it, I'm thinking, and we'll want to check for the player after our move and slide. So after we've moved and after everything's happy, we can just check to see if the player is within earshot. And the reason why I want to check if the player is in earshot far is because if we were to do this on every frame, then we're doing a lot of extra work and a lot of extra raycasting and things like that for no reason, right? So we want to make sure, has the player gotten in my earshot? Then I'm going to start actually tracking the player's movements. I'm going to track where the player is, how loud they are, things like that, right? So what we'll do is we will dump this out as its own function here. So that way we don't have some funky stuff going on. So we'll say func check for player, and we will go like that. We'll pass to kind of let it run through, and then we'll just come in here and say check for player. There we go. And then in our check for player function, let's set up a raycast. Now, much like we did with our character.gd, we actually have a little bit of code here that already does it. If I can find it, it's right here. We could basically just grab this guy like this, and then we could just come back to our enemy and legitimately just check like that, which is pretty great. It just we already have the code for it, so we might as well just use it. Now, if when we do our raycast, we don't want to just raycast from our position to 2 points above us, right? We want to check, where our player is, right? So what we can do is we can raycast from our enemy here to our player, right? Over here. Okay? But we don't want to raycast to our player directly, because if we raycast from our enemy, it's going to raycast from right here. Now we can do one of two things. We can either raycast from this point plus like 2, probably, or maybe 1.5, and then use that and have it raycast, or we could just place an object. And it's up to you guys on which one you want to do. In my case, I'm probably just going to go with an object. So I'm going to right click this, attach a child node, and attach a marker 3D. And I'll just drag this guy up to about here. That way I have a visual representation of where the guy's head is located, and I'll name that as head. And that'll just give me like an actual location, right? And then for my script, if I go back to it, what I'm going to do is I'm going to just say $head dot global underscore position like that. And then I want to raycast to my player. Now we do already have a way to get our player. I think if we go to our player, do we have a group? We do. So we could just go fetch our player through its group. So if we come here, we can just say get tree dot get nodes in group quote, and then player, and we'll pull back the first reference, because to be honest with you, we should never have any other than just one reference, dot global underscore position, and that should do it for that. So it's going to raycast to wherever our player is located. But we're going to want, instead to raycast to our global position of our player, if we come over here, it's going to raycast to here. So it's going to raycast to the ground of that player, and we don't want that. We want to raycast to wherever our camera is located. That way we can determine if the player is crouching or if they're not crouching, if that makes sense. So we can come into our script and go to our enemy real quick. And instead of just doing .global position, we can just say .get node, and we'll pass in our camera 3D .global position. And that will allow us to pull back our camera of our player. So that's this guy right here, a little camera 3D. And since the camera 3D can move up and down, it'll raycast either to here or to here, depending on if the player is crouching. That way we don't have to have that big, messy, multiple raycasts to recheck if the player is standing or crouching. We raycast at 2 different spots. Instead, we could just raycast at 1. And that makes things a little easier for us for code. So if we go back to our enemy, we have our raycast kind of settled. So now we can come in here and get rid of these guys because we don't need them anymore. This is where things are going to get a little bit fun. First, we have to check if it's greater than 0 because we know that we're going to raycast and get something back. Then we need to check if this is our player. So we can just check it by saying if result, and we can pull back our collider dot is, and I believe we have a check in here where we're saying is body in group. So we can just grab this guy right here and just say dot is in group like that. And if we are in group, then we can actually start doing all of our checking here. So what we'll do is we'll basically just run a quick if player in earshot close, then we can do some additional checking. So we know that the player is within our view. So think of it like if the player's hidden behind a wall or something like that. And we know that it is the player. And if they're in earshot close, then that means that we can check if they are in stealth. So if we head over to our player, which I believe is right here, we come up to the top, we do have a crouched Boolean here. So let's grab that. And we're going to need to make a lot of changes here, so don't worry. But if result collider dot crouched, then we can is equal to false, then we can go ahead and hunt after the player. So we'll type current state is equal to states dot chasing. So basically, if the player is not currently crouched, then the enemy is going to chase after the player. Now, we'll have to write an entire section for chasing to see, what it's going to do, but at least we have some of our code set up here. Now, we'll basically just copy this guy and paste him a few times because we're basically going to be doing the exact same thing 3 separate times with different Booleans. Now, I know what you're saying, like, okay, but if we have duplicated code, why don't we just, abstract it into a function? And the reason why is because in the future, we're going to make this into a more extendable system. But right now, it's just going to be a basic little, system that works, right? So we'll say player dot in earshot far and crouch is equal to false. Then we will say states dot hunting, and then we can do the next one, player in sight close chasing, which we already have, and then player in sight far, and then we can do hunting. There we go. And now we can basically just build out our states. And I believe we really only have chasing, hunting, and waiting to get done, but we already basically have waiting done. So really we just have chasing and hunting. So when the enemy hunts you, he's going to walk to your general location and then kind of just wait there for a second. And if you happen to be in that area, And really, if you're close, I wonder if we should just say when you're close, if you're crouched, it doesn't matter, like this and like this. That way it just provides a small, gameplay, to this game so far. I think that will work a little bit better. And let's space these guys out. Spacing is extremely important in code. It makes things feel a little bit better, a little bit, easier to read. At least for me, a lot of times I like to space my code out. Now, for chasing, basically all we're going to do is we are going to set the target location to the player, and then we are going to chase after that player. So we're basically going to duplicate this bit of code here. Now, you don't want to duplicate code if you can avoid it. So let's actually change this a tiny bit. So we'll write our basic chasing code, which is going to say, if your navigation is finished, then we will set our patrol timer dot start, and we will say current state is equal to states dot waiting. And basically, much like how we did up here when your navigation is finished, we're basically going to do the same thing. So basically, it's going to sit there and he's going to wait. And it's kind of like he's looking around the area. And once that finishes, then he's just going to go back to doing whatever it is that he wants to do, right? Now, we'll expand this to make him actually, search the area and maybe go into hunting. Maybe he'll go from chasing to hunting, right? We'll have to figure out what we want to do there. But for right now, I think that that's fine. And we will set our target location to the player position. So navigation agent dot set target location, and we will set it to our player's position. Now, at this point, we're starting to really use our player a lot. And instead of doing get tree, get nodes and group player 0, let's basically take this little bit here. Let's come up to our ready function. Let's create a var up here and say var player. And then we'll just set our player right here like that. And that'll just get us our player, so we have a reference to it. And then we can just come down here, and instead of getting our tree, getting our nodes and group and doing that, we can just fetch it like that. And then we can just pass in our player dot global underscore position like that. And then we need to run all of this navigation code again. And the problem with us doing an entire section here again down here is that it's a lot of duplicated code. So let's take this little bit here and let's abstract it into its own function so we can call that. So we'll say func move towards player, and we'll pass in our delta because we need to move over time, and we need to pass in our speed because if a player is being chased, I imagine that the enemy is going to move faster than his patrol speed. So we're going to want to pass in our speed instead of just using a global variable of speed right here. We can just pass in our speed. So we should call this is speed chase speed. And we'll also duplicate this guy and then do patrol speed. And we'll set the chase speed to 3 and we'll set the patrol speed to 2. And then when we come in here, instead of doing velocity multiplied by speed, we can just grab this guy and say move towards, and I probably shouldn't have called it player. I don't know why I called it player. I should probably call it point instead of move towards player, because technically it's a point. It's not a player, because technically we're going to be using it for both our patrol state and our chasing state. So it's not that we're chasing the player, it's that we're moving towards something. And we don't want to call it moving towards player if you're not moving towards the player. So that's my mistake. So with this, we need to put in 2 arguments, which is delta and the speed that we want the player to move. So since this is patrol, we can pass in our patrol speed. And then down here, we can just move towards point, delta, comma, chase speed. And then for hunting, we can basically do the exact same thing that we did over here. So we can just grab our chasing state and we can copy it and paste it, but we don't want this to happen every single frame, right? Because we don't want the character to get hunted and have them chase after the player, because that's what would happen, right? They would chase after the player. So when we change our state to hunting, we need to change our navigation target location. So we'll just grab this guy, come down here to where hunting is, and we will set its position right here. And that should do it pretty well for us. And then we could change this from chasing to patrol speed, and that should get the large majority of our system kind of, going. So I think we might be good. We can try it and see. So if we're standing and I move, now he's coming towards us, see? And once I've entered far sight, now that I'm in close sight, he is now following me. You see that? Because I am within close sight, which is awesome. Once I have left close earshot, let me see if I can get away from him. I don't think I'm going to be able to. He's chasing after me too close. There we go. I lost him. You can see that I lost him. Well, now he knows where I am, but you get what I was trying to show you at least, is that I lost him for a second there. See? I lost him. So now he's going to go back. Oh, and he saw me again. Well, I'm very bad at my own game. What can I say? So that's good news and bad news. So I'm glad to see that our code is working. He's chasing us. He's hunting after us and things like that. So if we reset our game and I stealthily start walking around, you can see even though I'm within earshot, he doesn't hear me. And that's good. Now if I move and I stealthily start sneaking around him, he should not chase after us. His timer's running, and now he's headed back. Okay. And there we go. And he saw me again. I'm very bad at my own game, apparently. But you get the goal of what we are trying to achieve. So that's awesome. So at this point, we basically have a very basic detection system built. Now, there is so much more that we need to do for this to actually work and to actually be, really solid. But that should get us at least to a good stopping point for right now. Now, in the next video, what we're going to do is we're going to create a light detection system. And basically, this system is going to allow us to say, depending on how far in shadow you are and how much light you have and stuff like that on your character, will determine if an enemy can see you. And that's going to make our stealth system way more dynamic and way more exciting. So be sure to look forward to that video. But that is all I have for you guys today. So thank you so much again for watching. And I will see you all next time. Thanks.